Good morning, good afternoon, and welcome to Smartlogic's webinar, Semantics in the Age of Digital Transformation. My name is Ann Kelly, and I'm part of the marketing team here at Smartlogic. And with me today is our Vice President of Solution Architecture, Steve Ingram. Steve has held many sales, product management, consulting, and management positions for market-leading software vendors such as IBM, Microsoft, Autonomy, and Verity. Throughout his career, he has a long and successful history of delivering exceptional value to organizations and their customers, including those with significant business impact. He holds a degree in computer science from the University of Exeter, and we're really excited about having him speak with us today. Before I turn it over to Steve, I have a few housekeeping items I'd like to go through. Just a reminder, this webinar is in broadcast mode and all participants are muted. We encourage questions and we encourage you to enter them in the GoToWebinar panel. If you look kind of down towards the bottom, you'll see it's a question section. Please enter them in there. And we'll try to answer as many of them as we can at the end of the session. This broadcast is also being recorded, and replay information will be sent to all registrants following the broadcast. And with that, I'm going to turn it over to Steve.
Thank you, Anne, and thank you all for taking the time to attend this webinar, or at least listen to the recording afterwards. In the next 20 or so minutes, I'm going to discuss why digital transformation is driving the need for insight engines, how relevance and meaning make this possible, and how semantics can deliver insight. On the way, I'm going to also cover the OODA theory of decision-making and how we can understand different modes of querying data. As Anne said, there will be an opportunity for Q&A at the end, so please type any questions in the chat box and we should address them in the last 15 to 20 minutes of this webinar. Let's first define what we mean by digital transformation. Gartner in 2008 identified the evolution of organizations towards what they referred to as the hyper-connected enterprise, where organizations move from a centralized structure towards a more complex and distributed configuration with contributions from suppliers, partners, and even external agencies such as customers. The challenge here is that as ecosystems widen and complexity increases, understanding decreases. Just as an illustration, consider the phrase gas. Now, does that mean what you put in your car or what surrounds us in the air? The answer you give will depend on what side of the Atlantic you're coming from. Similarly, different applications have different terminologies. Americans will say gas or gasoline, Brits will say petrol. An analyst may refer to it as petroleum. In the logistics industry, they refer to 3YE1203, which is the same substance, and chemists will use the chemical formula. It is the same thing, just different terminologies, different frames of reference. Another way of considering this problem is to look at the insight gap. This is the gap between the information that can be used to solve a business problem and the information that can be managed using traditional or conventional techniques. And this is a problem that is getting progressively worse over time. These days, solving a business problem data can come from a myriad of sources. Increasingly, organizations are looking to capitalize on information that's unstructured or textual. And as Gartner indicated, some of these sources will be external to the organization, including social media, for example, if you're recruiting or making an investment decision. And both external information, any form of information sourced from outside the boundaries of the organization will itself potentially be unreliable. Or you may even need to consider information that is implicit and has not actually been committed electronically. So in 2017, Gartner decided to revisit the market for search and related technologies that they had declared dead only a couple of years previously. And in their view, the market is now for insight engines, which have three defining attributes. They combine search and AI to deliver insights from across the organization, from across the enterprise. They use relevancy techniques to describe, discover, and organize data. And they deliver information to knowledge workers in context. However, there's considerable overlap in the market definition for search and for insight engines that we can actually use the same concepts to analyze both spaces. And in an earlier piece of work in 2014, the Gartner identified context-aware computing as a trend within the industry as a key step of delivering the sort of cognitive applications such as IBM Watson from the foundations of enterprise search and enterprise content management. Now, we're going to come back to this slide later, but hopefully that's the last time I need to mention the W word. But what do we actually mean by insight? And I'm going to need an expert to help with this bit. Allow me to introduce Colonel John Boyd. He's a remarkable man who probably deserves a webinar in his own right. He's a Korean War fighter pilot who, despite never firing his guns in anger, revolutionized fighter design and also gave us a handy model for the decision-making process. Colonel Boyd and his team developed something called the energy maneuverability theory of fighter design. Don't worry, I'm not going to go into the physics of thruster-weight ratios or drag coefficients, well, at least not this time anyway. The EM theory gave the world about $1 trillion worth of defense spending, including all the best fighters to come out of the US since the mid-60s, and also gave rise to the OODA theory of decision-making. Sadly, no prizes for guessing, which I'm going to be focusing on in the rest of this webinar. OODA stands for Observe, Orientate, Decide, and Act. And these are the stages that a pilot engaged in a dogfight moves through when engaging the enemy. But while few of us are ever likely to actually have to fly jets in combat, the theory also holds pretty much true for every decision a human makes. We all move through an OODA loop. Observe is where you evaluate your surroundings, taking in as much data as possible in the time available. Orientate is where you determine what are the key pieces of information you need to consider. Decide is where you evaluate options for addressing the most important factors. And act is when you actually do it. Now, OODA is a continual process. Every stage feeds into every other, and there is a continual feedback loop. The idea being that whichever pilot executes their OODA loop fastest is the victor, leaving their opponent crashing to the ground in a blaze of fire. And as an aside, Colonel Boyd believed that using this process he could gain a favourable position against any opponent in less than 40 seconds and won himself more than a few wagers proving it. Let's leave the world of air-to-air combat alone for a while and look at how OODA applies to business decisions. The 4 phases of OODA map nicely onto a series of filters which we can represent as a pyramid. Observe is all about data. It's the basic information where it's all the raw material for any decision we make. Orientate, the level above, covers what the military likes to refer to as situational awareness, i.e. what are the key points of the data and what is it telling us. Decide is all about recommendations, and act is all about actions. So we're probably not going to consider those 2 stages much further. Now, the keen-eyed amongst you may also be saying that looks familiar, as there are many similarities with the DIKW pyramid, so data, information, knowledge, and wisdom, which is a good model if all you want to do is accumulate knowledge. But businesses tend to want to do stuff with that knowledge, which is messy but unavoidable. Now, as we mentioned earlier, conventional techniques are very good at managing structured data. However, that is only 20% of the data available to an organization. The bulk of the data within an organization is unstructured or textual. And this is even more of a challenge when we look at the orientate or the situational awareness layers, as in many cases we'll be looking to leverage reports or analyst articles, news articles, and similar distillations of low-level data, which are generally still realized as text documents for consumption by humans. Now, search has become a major tool for delivering insight precisely because it is designed to work with textual content. It works on principles of relevance, sorting through large amounts of content to find you the document that matches your query. It has a low barrier for adoption. It's a paradigm that pretty much everybody knows how to use now, and can, if properly implemented, reach right across an organization. But as Gartner's Hyperconnected Enterprise report showed, this presents its own challenges as organizations evolve towards the hyperconnected enterprise. As complexity increases, understanding decreases. The further you are away from the source of the information, the more difficult it is to interpret what it is you're being told. But let's look at this in more detail. Our definition of situational awareness was our understanding of what is important. Understanding of what the data is telling us. The OODA theory says this is obtained by identifying the salient data items and, perhaps more importantly, identifying how they relate to each other. And it's the relationships between the data items that we will be handling when we come to look at the recommendation phase. Now, doing this looks simple on paper, but how are you supposed to know what is important, especially if that piece of information has been sourced externally or uses a different terminology to the one that you do? So we need to look more closely at relevance and meaning. And we're not entirely finished with OODA yet, though, so you haven't seen the last of this pyramid. So relevance and meaning. The search world has for years been focused on the concept of precision and recall, where precision is a measure of how relevant the results returned are, and recall measures how many of the relevant results are returned. And there are simple formulae, these are expressed as ratios, and there are simple formulae for calculating these values given the set of search results over a known corpus of documents. So precision is the number of relevant results over the number of results returned, and recall is the number of relevant results returned over the number of relevant results that are actually in the overall content. Well, maybe I should have gone back to talking about thrust to weight ratios anyway. The important thing to note is that different search applications will require different techniques, and so will bias one aspect of relevance or recall over another. So, for example, typical internet search, typical web search biases precision, so you're looking for single documents, single pages, single items of information, whereas a legal application will bias recall, because what you want to do is make sure you haven't left behind any documents that are relevant to the case that you're working on. So there is no one-size-fits-all solution for search, despite what certain vendors may have been telling you. And that is before we look at what is meant by relevance. Do I want the most recent document? Do I want the most authoritative document? Or do I want something completely else, something else entirely? And to answer that question, we need to understand what the user is looking for. Not what the user is looking for, but also what the user is looking for. The challenge for search, and therefore for insight engines, is that there are actually three types of query. The first, and the one people think about most, is when you're searching for a specific document. And this is always sometimes referred to as explicit search. And this is also the known knowns from the infamous Rumsfeld scale. So in this scenario, our blue search, Sir Sherlock, wants the 10K form for Oracle for the financial year ending 2015. Now, it's pretty easy to formulate a query for that. And any decent search engine should be able to return the document you need somewhere near the top of the results list. However, let's imagine that we want to research a particular subject. For example, Green Sherlock wants to know about Erwin Rommel's Africa campaign during World War II. Now, a query will return documents, but it is unlikely that any one document will contain all of the available information. Instead, there will be an aggregation of documents that collectively answer the question. And what our Green Sherlock will want to do is whiz down that list, put out the documents they need, and ignore the ones they don't need. So this is sometimes referred to as implicit search, where the answer is not in a single document, as with explicit search, but within an aggregation of what's coming back from the search engine. But lastly, we have the situations where we're looking for entirely new insights or eureka moments. So this is Autonomy's infamous show me something I don't know what I'm looking for. This is also known as tacit search. Now, say, for example, we wanted to increase our membership revenue by 25%. You're extremely unlikely to find the answer in a single document or even in a set of documents, as if it was already written down and already available, the business would already have done it. So instead, the answer to these sorts of questions may be in some kind of pattern in the search results, perhaps within frequently occurring concepts, or maybe some pattern with correlation of concepts, or some pattern around when the documents themselves were published, or maybe something to do with the source. In any case, it's not the documents that are important, but it's the metadata relating to these documents that will potentially give you your answer. So, for example, if I was researching US presidential elections, the name Nate Silver may be important, for example, but we may not have a document describing who Nate Silver is or what he does. If you were to plot conceptually the volume of searches against their value, you'd have a curve that looks something a little like the following. The bulk of searches will be requests for individual documents. They will be document search, they will be explicit searches. Research activity will represent a smaller volume. It's likely to be, it'll be a smaller volume than the document searches, but it will be a much higher value to the organization. And finally, a tiny proportion, probably tinier than the width of the line on this diagram, will be the Eureka searches, very small volume, but these can potentially deliver business-changing value. The key to the search value curve is to understand that a simple Google-style search interface is not going to get you much beyond document search, and will not enable you to deliver any of the higher order benefits. What is needed is to combine different technologies, so combining search with natural language processing to allow entities and relationships to be extracted and surfaced as metadata to enable the higher order decisions based on the search results. The ultimate objective is to derive facts from text. For example, there's little benefit from identifying the name Steve Ingram, the job title VP Solutions Architecture, and the company Smartlogic from a document. But there is more value if you're able to determine that Steve Ingram is VP Solutions Architecture at Smartlogic. Ultimately, we're looking for insight, or to put it another way, we're getting things from strings. And this is where semantics comes in. Now, well, there's a surprise. A semantics company says semantics is the solution to your IT challenges. Who'd have thought of that? Still, you don't actually need to take our word for it. If you remember the Gartner context-aware computing diagram from the earlier slides, let's take a look under that big blue arrow. Sitting squarely on the path to cognitive applications from the roots in search and ECM is managing the semantics of data. And once the semantics of both data and querying are understood, it's possible to create systems based on intent, i.e. do what I want, not what I say. And from there, it's a relatively simple step to the implementation of chatbots and cognitive advisors and sort of AI applications that are currently the rage at the moment. And more to the point, by managing semantics, you can base these context-aware systems on definitions that are shared right across your organization, not, as sadly is the case these days, by implementing yet another side-out application using potentially proprietary technologies. Said you'd see one more, you'd do a pyramid would appear again. This whole evolution from managing of search and content management through to cognitive applications is just the latest step in the IT industry's attempt to colonize the upper reaches of the OODA pyramid. Companies are continually looking to push up the point at which a human gets involved in the decision-making process. This means that the machines need to understand the text and be able to make recommendations that a human can put into action. And this is where semantics come in. But first, we probably need to define what we mean by semantics. At its simplest, semantics is all about understanding. And if you ever want a party game, just ask some information scientists to define semantics. Semantics is all about understanding. Semantic techniques is all about understanding what words, symbols, and data actually mean. We're back to sorting things from strings again. As an illustration, let's consider a simple exercise. Let's classify every book that's ever been written by the number of times it mentions either James Bond or Jason Bourne. And this is a simple enough task you could do with a simple string comparison program. So across one axis will be books written by Ian Fleming, and up the other one will be books written by Robert Ludlum. The vast majority of books, of course, will mention neither of them and will be sitting at that point where the green dot is. However, our simple algorithm will identify a number of documents that contain both Jason Bourne and James Bond. But what does that mean? We have no, apart from saying cluster of books with James Bond and Jason Bourne, we don't know what that means. We cannot attach a meaningful label to that cluster. Unless, of course, you understand that both of those are fictional secret agents. And in that situation, if you know that books that mention Jason Bourne are talking about fictional secret agents and books that mention James Bond are also talking about fictional secret agents, the books that talk about both of them are clearly discussing books about fictional secret agents, or some kind of weird mashup that has both characters, but that's neither here nor there. Now, we would be able to do this if we had a set of standard descriptions that could be applied to all books and all characters and all genres. Now, as it turns out, we do. So this is an ontology and describing a subset of literature. It has the characters and relates them to a genre, which is part of two other genres. Now, an ontology is just a map. It defines key concepts within a domain of knowledge, and perhaps more importantly, how they relate to each other. And it's knowing how data points relate to the ontology that turns analytics into insight. Without an ontology of some sort, search engines need to get very creative about determining what a document is about and ultimately what it means. And without an ontology to explain meaning, analytics are just numbers. But let's take a look at semantics in action. Here is an example of an adverse event report. This is the sort of thing that pharmaceutical companies need to handle whenever they perform a drug trial, and they may have thousands of them which they need to process if they're to proceed with a drug. Now, this one is just a simple string of text in a Word document. Now, I could get a human agent to read this. I may have thousands of these that I need to go process. I could get a human agent to read this to obtain the key information I think I need, but some of these words make my head ache, and the process would have to be repeated every time we wanted to retrieve a different piece of information or review different combinations of factors. An application using semantics can do the job much quicker and more accurately. So it could work through all the adverse event reports I have. But for example, for this one, it could tell me that the report is about a 73-year-old female who is taking Lunesta for insomnia and Ambien for migraines, who experienced syncope, now that's fainting to you and me, on the 14th of August 2014, and received an ECG on the same day. So if I wanted to see if there was any correlation between the age of the patient and adverse events, I would need to process all the documents to see which are the ones that were talking about 73-year-old patients and which are the ones where the patient was maybe below the age I was interested in. I don't need to do that. The semantics application using semantics can process all of that information, service it into a form that I can actually query, and to obtain the answers to the questions that I have. Let's look at another question, another example. This screenshot's from a prototype Health Explorer application. The user is interested in diabetes, and the application can show documents that are being classified as being about diabetes, either automatically or manually. But the user could also widen their query to related topics which are presented from a medical ontology. The key to this application is that the ontology combines terms that a patient or carer would use alongside terms used by medical practitioners. And the relevant terms can be provided based on the context of the user. But both sets of terminology can be used to browse the same content. And we can also make sure that relevant content is returned. For example, if I wanted to know about diabetes, I don't necessarily want to know about gestational diabetes, so I can make sure that there is no danger of those two concepts being applied to the same piece of content, unless it does actually describe both of them. So in this situation, we're using semantics to enrich both the content itself that underpins the application and the user experience. Users are able to come in from different frames of reference and use their frames of reference to navigate content that may be supplied by different teams. And this is using a combination of ontologies and automatic classification. Lastly, we have an example of how semantics can be used to provide understanding and harmonize vocabularies. In this situation, our user is looking to research child soldiers, and so it's searching on the website of an international NGO. But the NGO doesn't use the phrase child soldiers. It's not something that's meaningful to them, but they are offering them the alternative, which is child combatants. So my user can select that one, and then they're presented with search results that are guaranteed to be relevant to the query because they have been analyzed against the NGO's ontology and determined that they are about child combatants. They're also presented with topic-based refiners on the left-hand side that they can use to refine their research, so they can narrow down to a particular area. Or in the blue panel, they're also presented with information on the subject they're researching, links to relevant subjects, and further reading. And so the user here can take advantage of the captured knowledge that's inside the ontology to navigate their way through the content and find the answers to the questions that they posed originally. So these are all examples of many applications that have been developed using Smartlogic Semaphore, our product, which is around enriching information assets, extracting the key facts, and harmonizing to provide insight. So, to conclude, organizations are evolving. New requirements are emerging, and with them, new solutions to both new and old problems. The key to mastering these challenges is through semantics, is through the management of the ability to harness the analytics that are being generated by other products and artificial intelligence techniques to something that is meaningful to all the groups of users who will be applying looking at this system, and to using them to derive meaning. We are Smartlogic, and we've been delivering these sorts of solutions for Global 2000 clients since 2006. And we feel we're in a very good position to guide you through this sort of journey, and have been recognized by Gartner as a leader in the Magic Quadrants for metadata management solutions. And we are the leading pure play semantics player in the 2018 Magic Quadrant for insight engines. And if you have Gartner subscriptions, you can follow up on the two references on this slide. Our product Semaphore uses NLP and uses semantic models such as ontologies and taxonomies to enrich information assets, extract critical facts, and harmonize information sources to deliver insight. And we do it at enterprise scale. Now that is the end of my presentation. Hopefully you have a few questions for me, and even more hopefully they are questions that I can answer.
Thank you, Steve. We do have a few questions. Let me see if I can, oh, wait, we have a few more questions. So the first question is, and by it, I'm assuming you mean Semaphore. It says, does it support OWL2 statements in the ontology?
It supports OWL statements, yes. So the ontology is managed as a SCOS-Excel graph. If we import OWL statements, they're available alongside. So you can export the bits that we manage, you can export the bits that are relevant to OWL, and they'll be treated side by side for downstream processing.
Okay. The next question is, when you were showing the search value curve, entities in facts drive the highest search value, yet I think we all know that they're the most difficult to get at without complicated processes. You point out that, taxonomies really help that, but lots of people think they're time consuming and difficult and expensive to create. Are there tools or technologies out there that can be leveraged?
Yeah, that's a good question. Yes, so I think there's kind of two parts to that question. A lot of people feel that they're time consuming to create because they don't necessarily have the subject matter expertise or domain knowledge to be able to determine what needs to go into an ontology and what doesn't. So the first side of that is to make it very, very easy for subject matter experts to collaborate. So rather than require an information scientist to go and learn a particular aspect of the business, and provide tools that would allow the subject matter experts to directly contribute to the creation of the ontology. But on the other side of the equation is there are tools that can process either a corpus of documents and text mine it for key concepts, key terms, potentially key relationships, and then they can be used to augment other values that generally can also within an organization. There will be these definitions. They may not be referred to as an ontology or may not be referred to as a taxonomy. They will exist usually in spreadsheet form. So a good step is to start off by importing those and then to use the text mining tools to see how those definitions can be fleshed out.
That sounds good. Here's another one. Is there a capacity within Semaphore to do entity linking within the query phase at query time? And then as a second to that, is there an API that either Apache Solr or Elasticsearch can interact with?
I'll take the second one first. Absolutely. So we have there are APIs for all components. There's a pre-built connector for Solr. You can. I worked with a partner who developed a connector to Elasticsearch in about 45 minutes in real time. So it's straightforward to make those integrations. What was the first part of the question? Oh, it was.
Is there a capacity within Semaphore to do entity linking within the query phase at query time?
So we have within a consumer and retail application, we process the query from the user to determine what are the key, what is the context of the question, what is the product in and what is the issue that's trying to be resolved, and that is then used to route the user to a particular response from the knowledge base. I'm not sure if that's necessarily entity linking, but it's an application of the sort of classification and concept mapping techniques that we use onto the query, as well as that we also use on the data.
Okay, here's another one. How do AI and machine learning further enhance insight?
That's a good one. There are a lot of AI techniques out there. The main thrust, the main shortcoming is that the insights, you need to have some way of referring these insights back to the problem you're trying to solve. And this is where the use of an ontology to, if you will, mark the performance of the AI tools. So to make sure, to provide an additional level of meaning for interpreting what's coming out from the AI engines, or in some cases to act as a pre-filter to look at the information that maybe needs to feed into these learning systems. So rather than require an engine to learn about the concept of tax, for example, you could just make sure that you're using an ontology to retrieve all the information that's about text. So your machine learning engine just works on the facts rather than or works on the high value concepts rather than understanding that this is a document about tax, for example. And then also techniques around, we use machine learning techniques around refining the model and providing the clusters that can be used to provide additional evidence to a foundation taxonomy.
Okay, I have one more here. So when you showed the search value curve, where does the Smartlogic platform fall on that? I mean, how does it enhance that?
Well, we're not a search engine, but where we will enhance the platform is around the use of NLP, natural language processing techniques, to extract the entities, which we can, and then from there we can also look at how these relationships are defined to potentially extract relationships, moving up towards the actual extraction of the facts. And then those would be typically passed down as maybe RDF triples, and then you can start to use Sparkle to execute queries over the additional metadata that Semaphore has provided. So it's definitely it's above the document search level. It's enabling the ability to slice and dice a result set using for subject research, and also providing the additional metadata that can feed into the fact extraction and the Eureka search side.
Okay, that sounds good. I don't see any other questions. As a reminder, we will send a link to the playback and other information. If no one has any other questions, I guess we'll end our webinar. I want to thank everyone for joining us today, and thanks Steve for his great presentation. And I hope to see you again at the next webinar.
Thank you very much.